Hello, this is Dr. Shahriar Hossain again. We are starting workshop 2. Starting from today, we will be discussing machine learning topics using Python programming language. As I said early in this workshop series, these videos come from workshops that I ran for some experienced professionals in the software and information technology industry. Of course, for privacy reasons, I do not include the conversations I had with the audience. I create a voiceover for each of these videos. In the previous videos, you watched what I discussed with the audience about NumPy and Pandas. We are now moving toward some code machine learning algorithms using Python programming. Before moving to code machine learning algorithms, I explain what machine learning is. Machine learning refers to a set of smart algorithms that can learn from data to solve computational problems. You can consider that these algorithms become experienced by looking into data. Please allow me to give an example that you are already familiar with. You have your emails. Some of your emails are detected as spam. They move to the spam folder automatically. If a spam email arrives in your inbox, you probably report it as spam. Sometimes, if a legitimate email is automatically moved to the spam folder, you probably report it as not spam. In other words, you can report an email as a spam as well as you can unspam a good email if that good email was marked as a spam mistakenly. A spam detection software learns what types of emails are spam and what types of emails are not spam for you. That is, an email that is spam for you might be a legitimate email for another person. The spam detection algorithm learns from what they observe from your actions. The data regarding indications of spam and not spam can be used to make the algorithm more intelligent over time. A few more examples of machine learning are recognizing people's faces or recognizing the type of detected objects in images or videos. Such smart algorithms can be used to diagnose cancer regions, tumors, and many more complicated health-related situations. Machine learning algorithms are widely used for automation and many times for prediction. The use of machine learning in programming robots, predicting stock markets, and even automatic analysis of public sentiments from social media data is no more a dream. At this point, one person from the audience of the workshop that I was running asked me if I was talking about artificial intelligence. That's an excellent point. Machine learning is considered a part of artificial intelligence. One can say that machine learning is data-driven artificial intelligence. Machine learning also has considerable overlaps with computational statistics. Also, the phrases data mining and machine learning are sometimes used interchangeably, even though some differences can be listed between them. Whatever the terminology is, data science is all about open-minded exploration of data to solve computational problems. Therefore, you will see that data scientists come up with many different types of algorithms that resemble concepts from various disciplines. Let's go back to the topic that we were discussing. There are many machine learning algorithms depending on the relevant task you need to pursue. The two most prominent types of learning algorithms are supervised learning and unsupervised learning. There is a third type named reinforcement learning, which I did not describe in the workshop, but I will explain it here. Supervised learning is appropriate when you have supervised information with the data. For example, you have a bunch of emails. You have a table where each row represents how many times a word was seen in that email. Additionally, you have the information of whether this email is spam or not spam. In this example, the labels spam and not spam are the supervisions. A machine learning algorithm can be designed to learn what words are prominent for spam and what words are prominent for non-spam. Then, for any new email, the algorithm can automatically declare the email as a spam email or not a spam email based on what words are prominent in that new email. That is, the algorithm can apply its learning to detect spam. This type of solution is called classification. Here, there are two classes, spam and not spam. The algorithm learned how spam emails looked like and how the not spam emails looked like. Then it applied its learned knowledge to identify spam and emails that are not spam for new unseen emails. The faces detected on your social media images might have name tags, and these names were set automatically. Those name tags are sometimes results of supervised learning. The algorithm already received the supervision samples in the past from some other images. It trained itself using what it observed in the past. Now, for the faces in the new image, it can say which face is who. Let's talk about unsupervised learning. In unsupervised learning, we don't have any labels. That is, the data will not come with any supervision, and hence the name unsupervised learning gets justified. One unsupervised learning task is finding groups of objects in data. Finding groups of things from data is called a clustering task. For example, let's assume that we have a collection of images. A clustering algorithm will be able to group the images based on their similarities. In this example, these images will be in one cluster and these images will be in another cluster. Of course, we know that this cluster contains all the images of dogs and this cluster contains all the images of cats. However, the clustering algorithm does not know that. It does not know that the first cluster it created has all dogs. The algorithm only knows that these images have something similar. Also, the algorithm does not know that the other cluster contains all cats. The algorithm only knows that those images have similar entities inside them. The algorithm was never told how a dog looked like or a cat looked like. Hence, the algorithm was never supervised. The clustering algorithm just figured out on its own that there are two groups or clusters in these images. I have a more detailed video on clustering algorithms. I'll provide a link to that video in the description section. Some examples of unsupervised learning are finding which commodities in a shop are purchased together most frequently. Also problems such as if you have too many features, how to reduce the number of features to make computations more feasible. This problem is called dimensionality reduction. Now, what is reinforcement learning? Reinforcement learning is a reward-based learning mechanism. It is neither supervised nor unsupervised. How does it work then? Consider how children learn. Children learn with trial and error. When a child puts a toy inside the mouth, parents become anxious and immediately say, "No, no, no, you should not do that." When children try to draw something, parents praise them. That is a reward. Similarly, when she tries to walk, she gets a reward based on how she steps on the ground. The reward is being able to walk, and failure is falling on the floor. Similarly, a reinforcement learning algorithm learns from a reward mechanism. The reward mechanism is problem-specific. The reward is generally based on whether the state of the problem is closer to the goal state or not. Very well, we have some ideas about supervised learning, unsupervised learning, and reinforcement learning. We will start our machine learning Python coding using unsupervised machine learning. We will create a synthetic dataset first and then apply a clustering algorithm. The reason why we create a synthetic dataset is we will know the result of the synthetic dataset. Then we will try to evaluate the result of the clustering algorithm by trying to match the result of the clustering algorithm with the known clusters in the data.